this demo, we work a solution for mobile video delivery using ICN. And we're trying to leverage all the key features of ICN, basically mobility, support, storage support, and security. So here, precisely, as you can see, we are trying to focus on a communication over heterogeneous access. So you have a user that is connected both with Wi-Fi and LTE, and we're going to monitor here and below the traffic over Wi-Fi and over LTE and the split ratio between the two. And the application that we see in action is a dash streaming that we enhance with ICN. So we integrate ICN transport layer within a dash video player, standard dash video player, and we use ICN monitoring of the network interfaces to feed this information to the video player in order to adapt the adaptive bitrate strategy. So what you can see here, for instance, is that you are able to take the advantage of both bandwidth over Wi-Fi and over LTE, and to do an optimal split according to the available bandwidth over the two, and load balancing per packet the traffic over the two interfaces in order to maximize the overall bandwidth, which results from the sum of the available bandwidth of the two. And as you can see, as a result, we are really able to appreciate the video in a 4K quality, which is not the case where you are either using LTE or Wi-Fi alone, and without the transport layer capabilities of ICN. We focus on video because video is the most popular application that we're going to see no matter what the network architecture will look like. But what is really specific to 5G is this capability of supporting communication seamlessly over an heterogeneous access. So that's a technology that we really foresee as a promising candidate for 5G. And the other aspects that makes it really easier to implement in the 5G architecture is the network slicing. So here we are considering what we call VICN, a virtualized information-centric networking architecture that is deploying over a single slice. So you can have the coexistence like this in the network of legacy traffic and the ICN supported traffic, for instance, for video, without completely disrupting the current architecture and the existing services. So that's another promising feature of ICN. And then there are others that we hope to demonstrate in the future. We are already working on, like security. So the fact that you have an intrinsic object-based security model makes it much simpler to manage access control over different networks within a unified framework, and to really be bound to the data rather than to the connection. So that's something that really goes in the direction of simplifying the architecture through virtualization, through a connectionless transport, and through a tighter awareness of the network and of the content to better optimize the transport of the network. In this case, of course, we have video delivery, but I think we should pay attention also to the fact that we are able to minimize latency. So all the applications that require latency minimization can be well supported. We have a reliable transport. So what we were showing here before is that the fact that we can really make reliable even a medium like Wi-Fi, which is lossy by definition. So reliable application, that's something that we were able to support. It's really a network technology that you can optimize together with the application, as we do here for video, but it's really improving, if you will, the network substrate, making it more flexible to be modified in the future.